Hi there, Monty here with HKN with another linear controls problem. For this one, we're asked to find the transfer function of this mechanical system and then find an equivalent electrical circuit. So first thing we need to do is draw our free body diagram. This is a mess. We can see that we have a forcing function and everything that opposes it. So we have our spring, our dampener, and our mass itself. Keep in mind that these three are all forces opposing the other force. So drawing this, we know that the sum of all forces is equal to 0. So like so. All right. X plus B x dot plus M x dot dot equals F of T. I'm going to go ahead and turn this into S domain. Let me get it. So K x of S plus B S x of S plus M S squared x of S equals F of S. We're specifically looking for x of S over F of S. So I'm going to go ahead and take out a common variable and just reorganize this side. So I'll have x of S is equal to ms squared plus bs plus k equals F of S. Divide this over here and divide that over there, and we're left with x S over F of S equals 1 over ms squared plus bs plus k. This is our transfer function to our mechanical system. So before we can turn this into an electrical equivalent, you need to understand, I guess, the logic behind this derivative chain. So remember how I said that the force of the spring, put F of K equals Kx. And I'm going to go ahead and do this in the S domain. The force of the dampener is equal to Bx S, and the force of our mass is equal to M x of S squared. Okay, we used that the sum of all forces is equal to 0. So for an electrical equivalent, let's do KVL, where the sum of all voltages is equal to 0. So now let's find our voltages that we need. So obviously, first one we know is V equals IR. Another one we know that the voltage across an inductor is equal to L di dt. In the S domain, it's going to be L I S. And what's the voltage across a capacitor? Well, I know that IC equals C dV dt, which is also equal to CVS. So let me isolate my voltage. So VC equals IC over CS. So now we've got 3 kind of voltage parallels that we can use, and we can make our own ladder for it as well. So in this example, let me go ahead and put V equals IR. So that's our first one. But we also know that V is equal to I over CS. And I also know that V equals L I S. So let's set up a similar equation to this with that. So knowing that instead of forces, we're doing voltages, let me go ahead and make all this side LIS plus IR, let me do a capital R, plus I over CS equals, and we're going to have our forcing function of VS. So rearranged here, we can see our inductor, our resistor, and our capacitor. If you remember your impedances, this should be pretty straightforward, because what we're going to end up with is, this is our V of S. Let's go ahead and go through our inductor, L. Let's go through our resistor, R. Let's go through our capacitor, C. This is our equivalent circuit. Hope this helps. Thanks for watching.